Friends of the cosmos, stargazers, fellow travelers on this pale blue dot, greetings. 100 years ago, a discovery reshaped our understanding of the universe, a discovery that continues to inspire awe and wonder to this very day. In 1924, Edwin Hubble, peering through the lens of the powerful Hooker telescope, confirmed what many had suspected but none had proven. Andromeda was not just another nebula, a cloud of gas and dust within our own Milky Way, but a galaxy entirely separate from our own. Before Hubble, our cosmic perspective was rather limited. Imagine our galaxy, the Milky Way, as an immense island city, a glittering metropolis of stars, gas, and dust. That was the extent of our known universe, a solitary island in the vast cosmic ocean. Hubble's discovery was akin to finding another island city, far off in the distance, proving that our island city was not alone. The universe suddenly became a much larger, much more awe-inspiring place. Hubble's discovery was a watershed moment in astronomy, a paradigm shift that reverberates even today, a century later. It opened our eyes to a universe teeming with galaxies, each a swirling island of billions, even trillions of stars. And with that realization, a profound sense of wonder washed over humanity. But how did Hubble make this groundbreaking discovery? How did he reach across the vast gulf of space to determine the true nature of Andromeda? The answer, my friends, lies in the faint light emanating from that distant galaxy, light that traveled for millions of years before reaching Hubble's telescope. Hubble focused his attention on a particular type of star known as a Cepheid variable. Cepheid variables are special because their brightness fluctuates in a predictable pattern. The longer the period of their fluctuation, the brighter the star. By carefully observing the Cepheid variables in Andromeda, Hubble was able to determine their intrinsic brightness, their true luminosity. With this knowledge in hand, Hubble could then compare the apparent brightness of the Cepheid variables, how bright they appeared from Earth, with their intrinsic brightness. The dimmer the Cepheid variable appeared, the farther away it must be. And when Hubble performed these calculations, he realized that the Cepheid variables in Andromeda were incredibly distant, far too distant to be located within the Milky Way. Hubble's groundbreaking work did not end there. He continued his observations, meticulously measuring the distances to other galaxies and the speeds at which they were moving. And in doing so, he uncovered another profound truth about our universe, a truth now known as Hubble's law. Hubble observed that the farther away a galaxy is from us, the faster it is moving away from us. This observation suggested that the universe itself is expanding, a concept that had been theorized, but never before observed. Imagine baking a loaf of raisin bread. As the bread bakes and expands, the raisins within it move farther and farther apart. Similarly, as the universe expands, the galaxies within it are carried along for the ride, moving away from each other. This discovery, that the universe is not static but rather dynamic, expanding outward from a single point of origin, revolutionized our understanding of cosmology. It provided the first observational evidence for the Big Bang theory, the idea that the universe originated from an incredibly hot, dense state billions of years ago. The quantum revolution, a parallel journey. It's important to note that Hubble's discoveries were not made in isolation. The 1920s witnessed a period of unprecedented scientific advancement, a time when the very foundations of physics were being rewritten. While Hubble was gazing at distant galaxies, other scientists were delving into the realm of the very small, the realm of atoms and subatomic particles. This was the era when quantum physics emerged, a revolutionary theory that challenged our classical understanding of the universe. Quantum physics revealed a world of uncertainty and probability, where particles could exist in multiple states simultaneously, where energy and matter were inextricably linked. While seemingly abstract, quantum physics has had a profound impact on our everyday lives. From lasers and transistors to medical imaging and nuclear energy, many of the technologies we rely on today are rooted in the principles of quantum mechanics. Just as Hubble's discoveries expanded our understanding of the cosmos, quantum physics reshaped our understanding of the very building blocks of reality. The spirit of discovery, a driving force. So, what can we learn from Hubble's legacy from this era of groundbreaking scientific discovery? First and foremost, we are reminded of the power of curiosity, the insatiable desire to explore, to question, to understand. Hubble's work was not driven by practical applications or immediate societal benefits. It was driven by a pure and simple desire to unravel the mysteries of the cosmos. Curiosity-driven research, my friends, is the engine of scientific progress. It's the force that compels us to explore the unknown, to push the boundaries of knowledge, to ask the big questions, even if the answers are elusive or seem irrelevant to our daily lives. From the discovery of fire to the development of vaccines, countless breakthroughs throughout history have stemmed from curiosity-driven research. It's the foundation upon which we build our understanding of the natural world and our place within it. Telescopic titans, eyes on the universe. Of course, Hubble's discoveries would not have been possible without the technological advancements of his time, most notably the construction of large, powerful telescopes. The Hooker telescope, with its massive 100-inch mirror, was a marvel of engineering, allowing Hubble to see farther and fainter objects than ever before. Since Hubble's time, telescope technology has continued to advance at an astonishing pace. We now have telescopes in space, orbiting above the distorting effects of Earth's atmosphere. Telescopes that can detect light across the entire electromagnetic spectrum, from radio waves to gamma rays. The James Webb Space Telescope, launched in 2021, is a testament to our technological prowess. With its massive gold-plated mirror and advanced infrared capabilities, the James Webb Telescope is peering deep into the universe, capturing light from the first stars and galaxies that formed after the Big Bang. A future of exploration. The journey continues. We live in an era of rapid scientific progress, an era marked by artificial intelligence, quantum computing, and the burgeoning field of space exploration. We are sending probes to distant planets, developing new technologies to study the universe, and constantly pushing the boundaries of human knowledge. As we celebrate the 100th anniversary of Hubble's discovery, let us remember the lessons of the past, the power of curiosity, the importance of technological advancement, and the boundless potential of the human spirit. Let us continue to explore, to question, to marvel at the wonders of the universe. Keep looking up, my friends, and never lose your sense of wonder. The cosmos awaits.